It began snowing at 6 a.m. The thickness of the snow in my yard, measured in centimeters, is modeled by that function s of t equals 10t plus 17. It's going to be a lot of snow. T represents the number of hours since 6 a.m. So we're talking about like already seven. Who cares? What is the derivative s prime of t? And what does it represent in this context? Well, the derivative is going to be you using the power rule. So s prime of t is going to be the derivative of 10t, which is just 10, and then nothing. So basically, what does it mean in this context? Well, basically that 10, if you take the derivative of something, you get a rate. Since my rate has to do with two units, one being centimeters and one being time in hours since 6 a.m., you're looking at getting 10 centimeters of snow per hour. Holy crap. Wow. Well, all right. So that's basically what you're getting at. The rate of change of the snow thickness per hour. That's a lot of snow. Of course, not realistic here, but yeah, that's what it gets. And this kind of makes sense too, because if you look at this guy, it reminds me of like slope-intercept form. 10 would be your slope. So like, your slope is a rate of change. So it works out both ways. Also, the word thickness makes me very uncomfortable. Thanks for watching. Like and subscribe. A function p of x equals 2x squared plus 12x plus 16 models the number of people standing in a line at a movie premiere, where the input variable x represents the number of hours since midnight. What is p prime of 8, and what does it represent in this context? Well, let's first of all find out what p prime of x is. Okay, p of x is just a polynomial, so we're looking at power rule, power rule, power rule. All right, so the derivative of 2x squared is 4x. The derivative of 12x is 12, and then 16 becomes 0. Now, p prime of 8 is going to be 4 times 8 plus 12. 4 times 8 is 32, and 32 plus 12 is going to be 44. Now, what does this mean? So we found out p prime of 8 is 44, so part 1 is done. Now what we need to find out is what it means in this context. Well, 8 would represent 8 hours after midnight. So we could say at 8 a.m., the derivative being 44 means the rate of change, because that's what derivative gives us, the rate of change is going to be 44 people per hour. Okay, so you're given a rate of change, and at this time, 44 people per hour are watching this movie at 8 a.m., so at that specific time. So that's what it means in this context. Fun stuff. As you ride on a moving Ferris wheel, your height above the ground in feet is given by the function h of t equals 50 sine t over 2 plus 60. T is measured in minutes. What is the instantaneous rate of change at your height after 6 minutes? All right, so h prime of t, I knew that. What does it represent in this context? Well, what I need to do is I need to take the derivative of h of t and see what that means here. So this is going to be chain rule. This part right here is chain rule. Okay, 50 stays there. Take the derivative of the outside, which is the derivative of sine, and you get cosine. Keep the inside t over 2. Now I'm going to pretend that t over 2 is the same thing as half of t, so that when I take the derivative of the inside, I just view it as 1/2 of t, which makes the t go away, and I multiply everything by 1/2. Now, I'm not done taking the derivative yet, because the derivative of plus 60 is nothing. So h prime of t is 50 times 1/2, which is 25, cos t over 2. Now, finding h prime of 6 means I'm going to have 25 cos 6 over 2, which simplifies to 25 cos 3. Now, really, This should have been a calculator problem, and I didn't include a calculator here. Maybe when I created this, I should have included a pi. That would make life a lot easier. But this is just going to be some number, and I have no idea what that number is, okay? But whatever that number is, what it represents is the fact that we are finding a rate at 6 minutes. Now, I have feet and I have minutes. My rate, what this means, is going to be whatever 25 cos 3 is minutes per, no, I'm sorry, feet. I knew that was backwards. Feet per minute. So if I were to throw that in a calculator and find out what that is, that's what I would get. Okay? So when you take the derivative, you're finding a rate, and in this case, the rate is 25 cos 3 feet per minute, whatever 25 cos 3 feet per minute is. The graph of f of x is shown below. What is the value of f of 1 plus f prime of 1 plus 2f prime of 4? All right, f of 1 is going to be, what do I get when I plug in 1? I get 2, so f of 1 is 2, easy peasy. F prime of 1 is, what is the slope at 1? Well, the slope at that moment is attached to this straight line here, where it's going to be a slope of positive rise 2, run 1, 2, so my slope is 1, so f prime of 1 is 1. F prime of 4 is asking, what is my slope at 4? So I'm going to avoid using red. I almost did. So here's 4, right? It's attached to this line right here between that guy and that guy. So I care about the slope of this green line that I'm trying to draw out right there. This is a negative slope, so down 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4. So f prime of 4 is going to be negative 6 over 4 is negative 3 over 2. So when I put this all together, I want 2 plus 1 plus 2 times negative 3 over 2. 2 plus 1, these guys cancel out, minus 3. It's going to be a big fat 0. So a very bizarre problem, but again, the point of it is to make sure you understand what derivatives look like on a graph, and can you also do some regular PEMDAS while you're at it? And we can.